Hey, welcome. I'm here to talk to you about what I think the future of edge computing holds and how Daisho is working on realizing that future. Thank you all for coming. It's a little bit later in the day and it's been an exciting few days. Might be thinking about having dinner and drinks or going home, so thank you for still being here. I'll try to make my opinion as interesting as possible. Let's start with a few fun facts about myself. This slide has been put in by our marketing department, which is my colleague and friend Vakar. He is also our head of engineering and our head of product. Notice there's no marketing in there. He did some Google image searching, and this is what he came up with, because there's no images of me typing on a keyboard. It's actually from my days as a semi-pro cyclist. I don't have time to do any of that anymore. Because when I was joining Daisho as our first employee, I started out with architecting the first prototype of our platform. And since then, I've moved on to a little bit of more outward-facing role as chief technologist, dealing with ecosystems, third-party integrations. Although I've been basically living and breathing edge and things like microservices, Kubernetes, et cetera, for the last couple of years, I have a background in big data, distributed systems, was part of the core engineering team that built world's fastest SQL and Hadoop database. And before that, I was actually in consumer electronics, and I worked on projects that used digital video broadcasting to broadcast TV to mobile phones, back when nobody believed that there ever would be enough mobile bandwidth to actually stream TV. I think I've been proven wrong there. A little bit about Daisho, because you probably never heard of us. We're a fairly young company. We've been operating in stealth mode, and this is the first public presentation of our company and our platform. Our vision is be the industry standard for edge computing platforms. That's quite a lofty goal, but we're sticking to it, I think. It's, we really want, ideally, for all edge workloads to run on or with or cooperate with our platform. But that's to everybody's benefit, I think. Because we really think of edge computing as the next wave of digital transformation, in which it's all about workload mobility and leveraging existing and new infrastructure to bring applications closer to where the user is, to where the data is generated, to where the data is consumed, which should result into lower latency for everybody, which I think is a good thing. Actually, as Rob Howell said from Comcast in a keynote yesterday, latency will become what bandwidth is today. So the idea is that it will become the differentiating factor for telecom providers. We are headquartered here in Menlo Park in the Bay Area. When building out our company and platform, we quickly realized that the Bay Area is actually a really expensive place to do that for a startup. And we were fortunate enough to get in touch with a team of 4 really good engineers from Madrid, Spain, that were working as a team, and we could convince them to join us. It worked out so well that we grew and are growing our engineering team in Spain. The pool of talent there is actually really good, especially around networking. And we've got some really intelligent people there. We have a few people in the Bay Area there, but we also have a few remote employees. I myself am from the Portland, Oregon area, actually from a little town called Boring. That's a real town. There's a video on YouTube. You can look it up. I would play it right now, but we've got different things to do. Maybe if there's some time afterwards. So I know most of you are familiar with the concept of edge, probably all of you, edge computing, related terminology. Actually, the keynote this morning from Google talked about the edge quite a bit. There have been a number of presentations about it. Which is way different from what it was a couple of years ago. It's kind of legacy slide here, because if we started talking about the edge 2 years ago, I had to spend the whole 30 minutes explaining what it actually was. But I think it's still good to spend a couple minutes to convey how we think about the edge and what we think the real challenge is here. It's about an explosion of data that's being generated by users, by devices, IoT sensors, residential, industrial IoT, and all the data is just too much to be processed centrally. And to deal with this, there's also an explosion of distributed infrastructure, geo-distributed infrastructure, to deal with data where it's being generated. And that is the edge. That's already emerging. It's already there. But it has the potential of being an operational nightmare, because all that infrastructure needs to be managed as well. So that is the problem that we are solving. It's the management of applications and the infrastructure the applications run on to be able to process data as locally as possible to save cost and increase performance, lower latency. In a simple picture, if you have globally distributed users, for an optimal user experience, you need local processing. We just want to make users happy, right? But users can be real people, but also can be devices of applications that really rely on getting answers fast. So to that effect, we want to move the applications and the compute the applications run on closer to the users, removing round trips to centralized locations. And that's why we've been building our platform. It's a platform for edge computing as a service. It's called Nalej, which is spelled like that, but it's the phonetic representation of the word knowledge. Actually, if you type knowledge in Google, then it says knowledge, and then in the phonetic representation that, which coincidentally contains the word edge, so we thought it was pretty fitting. So in one sentence, it's distributed container and infrastructure management and orchestration system. It's based on Docker and Kubernetes. And ultimately, the Nalej platform gives you a unified view of all your infrastructure. And it really ranges from IoT, mobile, fog, private data centers, the cloud, all that combined is what we think of as edge. So we really think of all the separate clouds that people have been talking about the past couple of days, like telco clouds, edge clouds. We want to combine all of that in one unified view, and then let you deploy applications on top of that unified view of infrastructure, while the platform deals with figuring out where to run those applications best, if need be replicating it, reorchestrating it, and dealing with the connectivity between applications or various parts, various microservices of a single application. One of our investors summarized it as running arbitrary applications on an arbitrary set of resources. So how is that relevant to digital transformation, and how do we think it's relevant to this conference and to you guys here? So as I said, edge computing as a service, we really see as the next wave of digital transformation. Transformation to the edge, where infrastructure is abstracted and where servers and applications are orchestrated automatically where they're needed. But that really centers around the network. Because if you think about application mobility, you need to transport those applications. And you need to transport the state of those applications. And you need to transport data those applications might be needing. Also, you might run in unreliable environments, so you might need to replicate data. So it all really only works if you do the networking part right. And I think this puts telecom providers actually in a great position, because you own the network and you already have a bunch of edge infrastructure. So we started looking at what telecom is doing currently in terms of edge, and specifically we started looking at the core initiative, including things like XOS and ONOS, Trellis, Volva, SIBA, all those things. And we started looking at those and realizing these are applications that we can orchestrate. And we can orchestrate them next to value-add services from a telecom provider or third-party applications. And the more these workloads will be containerized, the more you can leave behind any legacy implementation, and that's digital transformation, right? So that brings us to how we think this is applicable to telecom providers, and we think of that in 3 phases. First, unifying existing infrastructure, then deploying cord on that infrastructure, and lastly, really orchestrating all the cord workload and services over that infrastructure. I'll go into a little bit detail on all of this. So firstly, you can deploy our platform on existing infrastructure. And I said it ranges from cloud, private data central offices, field offices, and local infrastructure like 5G cell towers or subscriber boxes, really the end-to-end chain of infrastructure. Once our platform is installed, and it can be by installing a simple agent on single boxes, it can be by hooking into existing Kubernetes clusters you already have deployed, or we can push out Kubernetes clusters fully automatically and deploy net new Kubernetes clusters. We might be running next to existing workloads, next to existing cord workloads, might be XOS, ONOS, stuff like that. Those are the blue dots here. Now, next to the existing workloads, we now can deploy other services, other applications. And given the fact that there's physical connectivity, might be actually managed by Trellis or ONOS, we provide connectivity between applications. So we actually have, it's called an on-demand peer-to-peer software-defined VPN that provides automatic connectivity between moving parts of an application, such that application developers don't really have to worry about the fact that their applications might not always run in the same location. It's actually close to what Larry was talking about yesterday and this morning with Istio and Envoy. It's kind of a service mesh, but it's more based on VPN connectivity. Drawback is it only does TCP and UDP right now. So there's some room for improvement and cooperation there. So we have this unified infrastructure, and now we can actually deploy OpenCord and all components of OpenCord on that. This gets you 2 things. First of all, you can now manage and deploy multiple central offices, multiple cord instances from a single central location. So you can actually manage your cord deployments. Secondly, you can schedule part of those cord services away from the central office. You can schedule them in field offices or up in other data centers or the cloud. At this point, we're just purely talking about the cord service containers itself and not necessarily the cord workloads. Those can still be scheduled by XOS. So we now have an application, OpenCord, running on our platform, and that application itself can manage workloads and manage infrastructure that we might not be managing at this point yet. So deploying a platform on a platform. So once all the cord workloads have been transformed into their containerized version, we can really start scheduling the cord workloads itself. And then you can really optimally schedule workloads and applications where they need to be, whether they're cord or other applications. So it can be third-party applications. You can open parts of your infrastructure for third parties that want to run super low latency applications on it. One of those applications can be ONOS or Trellis, and the idea is that you can automatically figure out what data centers, what locations are OpenFlow enabled or P4 enabled, and then schedule ONOS there. So it's really about figuring out, oh, this application needs a certain set of resources or capabilities, and then, oh, these are the locations where those resources and capabilities are. That's where the application is going to run. So what's the opportunity here, and why now? So there was this first idea of digital transformation where you move from a monolithic workload, because virtualization became a thing. It allowed you to move from a monolithic workload to a cloud workload, and that move made things more flexible, but also enabled really mobile applications. So that was cloud transformation. Now from there, containerization, we think, really enables the move from cloud to a world where you have microservices that can be flexibly deployed to the edge, where you can move your workload towards the edge. Network plays a crucial role in this, as said. So I think this edge transformation isn't only enabled by containerization, but also definitely by telecom providers and the network infrastructure there. And that will make existing applications work better, will make existing applications lower latency. But just as the cloud transformation opened up mobile applications, I think edge transformation opens up a whole new world of low latency applications that weren't actually possible before. One of those applications is actually from a POC we have with a company we are partnering with in Europe. They are trying to build something. They're designing something they called unmanned aerial vehicles, basically drone taxis. So fly up in the air and get transported. And this is an example of an application where low latency really is the difference between life and death. All those drone taxis need to really look at their surroundings, look at the other drone taxis, make decisions on direction and speed and evasive actions. That's a large amount of data that needs to be processed really fast. So the only way to do that is to move the processing close to where the action is. So move it to cell towers or move it even on the drones themselves. They probably have processing power. And you also probably want the really life or death decisions be made independent of cell networks, because you guys are pretty good at building cell networks, but wouldn't trust my life to it still. But you need to schedule all of that. You need to orchestrate all of that. So these are applications that the edge will allow and are not possible right now. So it's the goal of Daisho to make this vision possible. But it's also our goal to make this as easy as possible, and to make people use their existing expertise and their existing tooling. As developers, as operators, or whatever role you are in, we want to let you use things you already know and not introduce additional complexity. That's the whole goal. We want you to be unaware of the fact that your application might be deployed in many different locations, and your application might be moving, and your application might be talking to other applications that might be moving. Our platform really takes away all that complexity and makes that transparent for users of the platform, developers on the platform, and ultimately for end users. So where are we with this, realistically speaking? We are currently engaged with a number of network partners, with a number of telecom partners, some of them members of ONF, and we are on track to release a first publicly available alpha version or invitation available. You can go to the website daisho.group to get more information, get an invite for demonstration and alpha deployments. So far, we actually have been focusing on fairly generic workloads, but we have been experimenting with cored workloads as well, and we see a ton of potential there to actually orchestrate those. Because, as I said earlier, we really think there's two big opportunities here. One is for internal services to be scheduled, like all the cored services, and then for third-party services to be scheduled. So give customers a way to deploy low-latency edge applications in ways that people like Amazon are not able to do right now. So we actually have been playing with Kashengo hardware, which is ARM-based compute storage network in a single enclosure, super high density. Running an ARM port of OpenCore on there and orchestrating on a number of those boxes, because it was an easy way to get to a fairly high density edge without actually having edge hardware. But we really are looking for people to partner with, to collaborate with us on real world edge workloads, so we get a real good insight on what is needed and what is out there, and get a good understanding there. You know, even just do some quick experiments and quick POCs. So on the website, you can fill out a form, and we'll talk more. That's it. Any questions?
Thank you very much for your presentation, and I'm quite happy to hear. I think that you are the first person to emphasize on the application layer, the orchestration.
Right.
So yeah, everybody here is actually talking about the network side, yeah, the orchestration. But okay, so it's really good to hear that. And so my question is that actually, you have any the application layer orchestration methodology or any system you have? That's the first question. And the other question is, do you have any other specific application or services you have make some demonstration?
So good questions. Our orchestration methodology is basically we orchestrate over different Kubernetes clusters. So I actually have a slide. I'll probably confuse more than anything else. Now, what we currently do, we are you basically give us a Docker image or a set of Docker images and tell us how those talk to each other, how they interact. Not unlike you can do with a Helm chart. And we have our orchestrator then figures out what hardware they should run on. One example that we have in a demonstration is something simple as an IoT household energy reader that has a component that runs actually on-premise at a residential household to gather metrics, send those metrics to a nearby central office or field office to store those and do some pre-analysis, and then send them up to a central location for long-term storage and big data analytics. So that's really the type of application hierarchy we have seen so far.
Hi, from the programmer's perspective, how conscious in the experience that you have so far, how conscious must the programmer be as to the placement of parts of the application in proximity to the user? Is it something that they discover through trial and error, or is there a systematic process by which the system and or the programmer has to guide the system?
That's a great question. So ideally, what we aim to do is if you have implemented your application as a set of microservices, and if you have implemented those assuming network failure, like properly retrying if there's no connectivity, ideally that's all you need to do. And we aim to inspect network traffic and where it originates, where it goes to, combined with resource capabilities, resource availability to make it all happen for you. At this moment, we need some more information, more hints from the application developer as to where to put the application. But ideally, this should be fully automatic.
So I have a question. It wouldn't take advantage of any super intelligence of placement because you'd know where you want to put functionality, but you said Helm-like.
Right.
So imagine one of the things that we'd like to do is you're not a global carrier, but you want to install SIBA
Right.
at a small number of sites, and just managing that from the cloud would be a really helpful thing. Does that fit? So you could, all right.
No, that's definitely something. I mean, I'm painting here a picture of like, oh, these big globally distributed networks and edge and everything. But we're actually doing POCs where it's really one location where there is small device on a factory floor and a data center with more compute where now a service tech needs to go in with a USB stick to update all of those. To manage it, that is already something that.
So beyond the placement,
yeah,
just in terms of operating what you had then deployed, is that part of the?
Yeah, so we do monitor applications and we do profile applications that are running and make sure that they still are running, and if they go down, restart them in the same location or elsewhere. So it's also really meant as a management system for applications.
Okay, great. So one last little follow-up is, from where? Is this something that I could launch in Amazon or Google?
Yeah.
Okay.
So the service orchestrator, the like platform control point, you can run it anywhere too. You can run it in your own data center or on Amazon. We actually plan to, in January, have it running ourselves as a service where you can sign up for and orchestrate your stuff from there, but you can run it by yourself as well.
All right, thank you very much.
Thanks.